So let me close in this session by saying that one of the slogans of MSR is turning ideas into reality. And indeed, that's what we do in Microsoft Research. And here you see a list of the things that you have seen in this during the course of this presentation. And Kinet identity, Kinet-based object digitization, and Avatar Kinet, these are actually shipped as real product and being used by tens of millions of people out there. So it's very exciting. So natural user interface, in many places, it's science fiction. But at MSR, it is not science fiction. It is very, very real. And we use this technology, we develop this technology, and we put in the hands of tens of millions of people, and they are using it every day. Okay, thank you for your attention.
Thank you, Bai-Ning. It is now my honor to introduce Katsu Ikeuchi. Professor Ikeuchi has watched Microsoft Research for 20 years, including MSR Asia for the past 13. He has been our longtime collaborator and is also an advisor on our MSRA Asia technical board. He has greatly helped us to establish MSR's engagement with the academic communities in Japan. Professor Ikeuchi is always very productive. Even when doing all of this work, he still remains a premier figure in computer vision. Furthermore, he is a pioneer in using IT technology for the preservation and dissemination of cultural and natural heritage. We were inspired by Professor Ikeuchi to start a serious effort in this area, and we have been able to generate strong results. Now I am pleased to introduce Professor Ikeuchi, who started the eHeritage program at the very beginning, and he will tell us both about the importance of and the latest state-of-the-art developments in this area.
Let's see, where is the mouse actually? Yeah. Okay, so today I would like to explain our project called eHeritage. And first of all, let's see, I have to practice. What is eHeritage? Basically, eHeritage is digital data transformed from real heritage. And in this process, we have three processes. One is how to obtain such data, and how to process such data, analyze data, and also how to display such data. And in this particular presentation, why we are developing this eHeritage? Because heritage is priceless, irreplaceable, and everyday vanishing. And in order to safeguarding, we have to create such eHeritage. Also, scientific analysis and data contents for generations. So eHeritage provides ample opportunity in computer graphics, computer vision, and also computer science too. Now, acquisition. Basically, research issue is how to design new sensors as well as how to design softwares to process such huge data. And this is one of the examples called Bayon temperature balloon sensors. And some of the heritage has high viewpoint, so we have to design peculiar sensor. In this case, we hang sensor under the balloon. And of course, that provides the freedom to choose a viewpoint. However, obtained data is like this. And challenge is how to rectify such data. By combining image sequence and this data, we can rectify this kind of data. Another area where some of the area is quite narrow, so again, we have to develop new sensors that provide quite a good view of narrow areas like this. Also, not only shape, but also you have to worry about the colors. And in particular, heritage has special spectrum, so we develop a sensor to acquire entire whole spectrum immediately. As a conjunction of this eHeritage project, we begin to work on Dongfang Cave as one of the target. And we apply Microsoft Research Asia apply Gigapixel to the Dongfang cave. And this is a scene where Moshe's Gigapixel is working on Dongfang cave.
敦煌莫高窟啊，它是我们国家少有的文化艺术瑰宝。这么一处瑰宝，但是面临着这么一些保护上的问题。一个是自然灾害，还有一个问题，就是人为的破坏。文化遗产它是不能再生，它也是不能永生的。这个问题呢，是敦煌莫高窟面临的问题，也是其他的所有的全世界的文化遗产面临的共同问题。会让工人知道了我们在保护啊、展示方面的需求以后啊，就给我们制成了一部，实际上就是10亿像素的一个相机。这样的一个相机，我们经过拍摄以后啊，这个效果确实非常好。
The Gigapixel camera can capture high-resolution, large-format images and can easily resolve details that are not visible to the naked eye. The Gigapixel camera automatically computes a synthetic focal stacking function which greatly increases the depth of field. The greatest advantage of this technology is that it meets the needs of Dunhua scholar for capturing large number of three-dimensional shrines to the finest degree.
The social responsibility is the cornerstone for Microsoft's long-term sustained growth and development. Leveraging advanced information technology to preserve nature and cultural heritage is always a priority for Microsoft. The innovative development of Gigapixel Camera and its application to Dunhuang project is the best example of such accomplishments in eHeritage program. In the future, Microsoft looks forward to collaborating with more researchers around the world to make more contribution to natural and cultural heritage preservation, so we can live a more genuine past and create a better future for our offspring.
In fact, this is not the end of the story, rather beginning of headache. We have obtained huge data from various viewing directions, so next challenge is how to connect all together, so-called alignment. There are huge data, so it takes long time to computation, and also we need a large memory areas. And of course, we have to design various softwares, quick pairwise alignment algorithm by using GPU, and also parallel simultaneous alignment algorithm running on PC clusters. And by using this kind of technology, we can connect all together terabyte data into one of the uniform manner like this. And in this case, 150 meter, 40 meter structure is represent 1 centimeter resolution of mesh, not point cloud, rather mesh data. Now, once you obtain this kind of data, next issue is how to use such data. And of course, we can use video contents, but not only video contents, but also we can analyze such 3D data for archeological research. For example, in this Bayon temple, from this archeological data, we can make a cross-section. Then it turned out entire structure of Bayon temple is rotating 0.94 degree counterclockwise. We obtained 173 faces. It turned out by using computer analysis, we can classify 173 faces into 3 graphs. Deva, Devata, Ashura. And before us, there's no picture of the hidden pediment. But by using range sensor, range data, we can obtain synthesized pictures. And then this is a picture, and apparently central area, originally there was a Buddha carved out, represent linga, meaning from this picture we can guess probably this temple was religious is changed from Buddhism to Hinduism. So by using this kind of 3D data, we can conduct so-called cyber archaeologies. Next example. We scanned one of the tumulus in Japan. And originally, people believe this painting was done under torch. But by analyzing spectrum of this wall and run a simulation under torch and under sunlight, some of the edges visible under sunlight, yet invisible under torch, meaning it is most likely this painting was done not under torch, but sunlight. Who cares? Well, if it is done by under sunlight, originally people believe first they complete tumulus and then people go inside and paint. But it isn't. Actually, half completed only wall, paint, and then make ceiling and tumulus. So such 3D data and spectral analysis provide new finding for archaeologists. Third, actually, presentation. Now you have interpretation, 3D data, color data. What can we do? Of course, we can show, but in my opinion, that all data should be uploaded to the cloud computers so that everyone can use every occasion, motivation, orientation, excitement, visiting, and even sharing the comment of that site. Let's take a look at motivation. What is the challenge? Well, motivation. Basically, we can motivate to visit site by using website, but 2D, it's okay to download, but if it is terabyte data of 3D data, what we can do? Challenge is how to access huge data through narrow channels. And one of the students is working with Microsoft Redmond to solve these issues. He called network rendering. Download LOD 3D data and pre-rendered image combined. And this is a preliminary terminal he created recently. Easily you can see huge data through this small channel of the facilities. Second issue, orientation, where this is storytelling and how to create contents from 3D data is another issue. On-site excitement. When you visit some of the site, this kind of situation happens where there is dirty ruin exists. And of course, if you have rich historical knowledge, you are impressed. Yeah, this is important site. But if you bring school kids, they never understand the meaning of this particular site. Just sit down on this ruin and have a lunchbox and disappear. And this is not good. So is there any way to make school children understand importance of this site? We are proposing this mixed reality display. You can enjoy CG exactly on the site, feeling wind blowing from ancient time continuously. And we are implementing this system. And what is technical challenge? Well, one of the technical challenges is photo consistency, where these two objects appear exactly same positions, this one and this one, but this looks floating while this guy is on the table. Why? Because this guy doesn't have shadow while this guy has shadows. If you visit site, temple is floating, it is not good. Of course, temple should be on the ground. So we need photo consistencies. And we are working this one, how to generate real-time shadows. And this is a videos. As you see, this video changing illumination condition, it color change. This is illumination change from noon to sunset. CG change along the background change. Also, if that is a famous site, there are many visitors like this, and this kind of situation occurs. And of course, we cannot exclude the visitors. What can we do? Real-time segmentations. This is a background image. Important point is, visitors appear in front of CG, but not only that, but also shadow of visitor is projected on this graphics. And this is a scene which we are conducting, so-called Among Us Hill. The girl is wearing glass, and then over this ground, you see the virtual palace. Now, visiting. Well, usually visiting, of course, you have to move around, but wasting time, actually. And we are proposing, is there any way to utilize such time for education? And what we are proposing, while you are moving, if you can see background image, then that is much better than just sitting on the seat. And this is a scene which we are implemented. One of the technical challenges is how to locate viewers' viewing direction as positions. And second issue, not only building, but also for understanding, event is important. And event usually involve human beings. And we are developing system to extract only character from movies and paste on the scene. And this is a scene which we are using, doing. And this is a tram which we use for these demonstrations. And of course, passenger is wearing this strange goggle by using a mobile phone. And this is a real scene. And on this real scene, CG is superimposed. Even some of the characters, some people are chattering, and even you can join some of the ceremony by using this tram. So we are calling this a time machine. Now you are impressed. Probably you want to share that comment with other people. And what we are developing is we can post your opinion or whatever knowledge to the 3D itself, so that later people can retrieve your opinion or whatever from this 3D data. So we are storing data directly on this 3D data. Now, once you register your data or opinion or whatever, later people can retrieve that data. So these are the story of eHeritage. Computer vision for eHeritage sensing, cloud computing for eHeritage representation, computer graphics for eHeritage display. And this eHeritage provides safeguarding heritage, scientific data, and content generation. And we can utilize such knowledge through cloud computers. And since this eHeritage is quite challenging areas, so young researchers should join our direction. Thank you very much.